All right, guys, I'm going to do 5, and then I'm going to give you the information you need for 7. You're going to need to plot the points for 7, but I'm going to draw a sketch of what that function is going to look like after you plot the points and give you the equation because you don't have a graphing calculator to use and you won't be able to do the regression for it. All right, let's start with number 5. Number 5 is a graph, so it's kind of like the first page. Well, if you are looking at number 4, f of x and g of x, it's like those, except you have to take those roots that are shown here and you have to put them into factor form. Now, these 3 are roots. This is not a root. That's a y-intercept. So if these are your 3 roots, let's make factors out of them. So this first root, -4, becomes the factor x plus 4. This -3 comes from the factor x plus 3, and that -2 comes from the factor x plus 2. Once you've set those up, then you're going to start multiplying. Now remember, you're just going to do one set of binomials first, then we'll deal with this third set later. Do these 2 first. So you're going to do x times x, then x times 3, then 4 times x, and 4 times 3. So x times x is x squared. X times 3 is 3x. 4 times x is 4x. And 4 times 3 is 12. Those are all positive numbers, so we give them all plus signs. What we've essentially done is taken these 2 binomials and condensed them into one binomial. So they're still in parentheses. You can't forget that you need that parentheses still. You can't drop the parentheses. And this x plus 2 we haven't done anything yet with. And we're not going to do anything with it still because there's a little bit of combining like terms that we still have left to do. 3x and 4x are like terms, so I'm going to circle those so that we know that we can combine them. 3x plus 4x is 7x, so this is going to become x squared plus 7x plus 12. And that is still there. So we're not done yet. We still have to multiply by x plus 2. Just going to recenter here to give us some space. All right. Now we're multiplying a trinomial by a binomial. So we're going to do x times x, then x times 2, then 7x times x, and 7x times 2, then 12 times x, and 12 times 2. X squared times x is x cubed. X squared times 2 is 2x squared. 7x times x is 7x squared. 7x times 2 is 14x. 12 times x is 12x, and 12 times 2 is 24. Now there are some like terms we can combine, so I'm going to use circles around the like terms that have an x squared, and then I'll box the ones that are an x to the first. Combine like terms, that's going to leave me with, and I'll put my answer in this space for where the equation should go. F of x equals x cubed plus 9x squared plus 26x plus 24. And that's it. We can't combine any more like terms because we have cube, squared to the first, and then a constant. There's nothing else we can do to combine here. All right, so that's your equation. That was the part that takes the most time. It's just a bunch of multiplication. Now, from this equation, we can determine the y-intercept. Remember, our y-intercept is whatever the constant is that's on the end. So the y-intercept in this case is 24. But we wouldn't have to necessarily just look at the equation here because we're actually given the graph. We can see that it's 24 because that's where our function crosses the y-axis. So 24 is definitely our y-intercept if we choose to check it that way. The roots, well, we had those from the start. So our roots are x equals -4, -3, and -2. And the last thing is the end behavior. Now, this is the thing that's been giving people the most trouble. So I'm going to zoom out and we're going to look at this whole picture here. As x decreases, so as x moves this direction and heads towards -infinity, what does this end of my polynomial do? As we go this direction, now it's dropping off, and it's going to drop off forever and ever and ever. So as x approaches -infinity, y is also approaching -infinity. So I'm going to write that y approaches -infinity as x approaches -infinity. That's one side. Now let's talk about the other side. As y approaches positive infinity, so now, or x, I'm sorry, approaches positive infinity, as we go this direction, positive infinity, and we travel along our polynomial with x increasing towards positive infinity, towards the end, now y increases, and it's never going to stop increasing. So in that direction, y is approaching positive infinity. So y approaches positive infinity as x approaches positive infinity. All right, so that was kind of a long video, you guys, because there's a lot to explain there. I hope that makes sense, and let me focus it in so you can just look at what we've got left. And I'm going to do a second video, and we'll talk about number 7 in that second video, just so that we can keep these videos short.